To get the most out of this course, you're going to want to do more than just listen to me talk and watch video. You're going to want to try programming yourself. To do that, you'll need to know what tools to use to write programs, how to save programs, and how to run programs on your own machine. I'm going to talk about 3 ways that you can use free tools to write C++ programs. The first and easiest way is to use a web browser. And you can do this from just about any computer that has a web browser, even a smartphone. Though of course you'll find it much easier to write code if you have a full keyboard. Now, using a web browser, regardless of your computer, has some limitations. But it's a good option if you have an especially old computer running an old operating system. And, regardless of operating system, sometimes it's more convenient. So I want everyone to be aware of this option, and I encourage you to give it a try. The other 2 options that I'll discuss involve downloading software to your own computer. And this software is called an Integrated Development Environment, an IDE. And either option will include both C++ itself and also a first-rate set of tools for using C++, all in just one download. First, I'll give some pointers for troubleshooting your download and installation. On a PC, the IDE I recommend is called Visual Studio. The free version is called the Community Edition, and it will have everything we need and a whole lot more. Now, paid versions of Visual Studio are geared toward teams of professional developers, so it's more complicated than we want for this course. Visual Studio is a great product that can be used by novices or by people developing the most powerful programs there are. Visual Studio can be even used over a wide variety of other languages, though we're just using it for C++. On a Mac, the IDE I recommend is called Xcode. Apple supports Xcode as an IDE to build apps for Apple products, where the default is a programming language called Swift. However, this same IDE can also develop apps and other programs in C++. And in fact, it's widely used for C++ programming more generally too. These are environments that are easy for beginners, but also used by professionals. Now, note, these options may not work unless you have a PC computer with a recent version of Windows, or a Mac computer with a recent version of the Mac OS, along with a couple of gigabytes of memory storage available on your hard drive. If you're lacking any of that, just stick with the browser option for now. If you need to move back and forth between a Mac and PC, you might consider other options, such as one called Visual Studio Code, but I won't be discussing any of those other IDEs here. Now, if you happen to be using Linux, then I'll just mention that the GCC compiler is your best option. And this was probably installed automatically together with Linux. But if not, you can go to gcc.gnu.org to get it. C++ itself has been updated over the years, from C++ 11 to C++ 14 and C++ 17. And the newer versions add some more features. But for what we do in this course, C++ 11 will be sufficient. Lastly, I'm also going to describe how to get a basic Hello World program running. It's just a few lines of code from the #include IO stream using namespace standard and int main lines that begin the program to the cout line that actually instructs the computer to print Hello World, and finishing with a final curly brace. Once you've got your software environment set up, feel free to explore the interface a bit. It's fine if there are features that don't initially make sense to you. You'll gradually learn more about the various options as we go through the course, and as you develop code on your own during and after the course. Let me also encourage you to stop the presentations regularly throughout the course and try writing the code for yourself, and maybe even making small modifications to it as you feel comfortable. Implementing and experimenting on your own is one of the best ways that you'll actually learn the details of how to code in C++. The easiest way to get started with C++ is to open a web browser on your computer. Here, any browser should be fine. Chrome, Microsoft Edge, Safari, Firefox, Opera, Internet Explorer, or anything else. From your browser, you'll be choosing a website that offers an online editor for C++ that is interactive. Now I've listed here some of the websites that I think work well, but a web search for online C++ compiler or interactive C++ compiler will turn up some others that should work fine too. There's one pitfall to watch for. Use only sites that support interactive mode. That is, if you're going to be using a browser-based compiler that's not on my list, make sure that it does support interactive mode when executing a program. How can you tell? Well, here's some code that's interactive. It's a version of the Hello World program that also takes input. If you run this in the browser, an interactive mode will prompt you for your name, and you can type that right there. But if you only see a box, often labeled stdin, short for standard input, where you type input separately from where you see output, that's probably not a good sign. On a site that's not interactive, you would have to enter all of your input beforehand. It would not be possible for a user to reply to a question and have the program compute a result. You should be able to run the program and then interact with the output window to type in data when asked. Now, feel free to select whichever site you find easy and intuitive to use. I think cpp.sh is especially simple and clean. OnlineGDB is more powerful. It goes an extra step and offers an online debugger, something that many interactive sites lack. The steps are simple. Type a web address in your browser. Then select C++ as the language. Some online websites handle other languages, and sometimes a different language is selected by default. You may need to select C++ from a drop-down box or open a new tab for a C++ program. Then, save your code in a text file. Your code is not being saved by typical online websites. So, you should expect to write and save your code in a text file and paste it over into the browser. A few sites may offer you an account, and if so, such a site might let you actually save your code there. But generally, your code will not be saved on the website. So, let's see what it takes to actually type in and run a program. Now, regardless of which browser-based compiler you chose, when you bring up the web page, the first thing that you're likely to see is a box of some sort, with an example program already in it. That's the main window, where we'll enter our program. And there might be a variation on our Hello World program already there. The main window is where we'll enter our program. Let's first start by deleting what's there. Just highlight all of it, and then press the delete key or backspace key on your keyboard to get rid of it. Okay, now let's go ahead and enter our Hello World program. Since the browser won't save your program, type this code into a text file, and then copy and paste it into the main window, where the old program used to be. Now you may notice that the code is automatically assigned several different colors for you, though some of these colors may be less obvious when the font size is small. And these colors make it easier to see the structure of your program. For example, keywords like include, the built-in commands that are part of C++, might be blue or possibly orange. Text in quotes, such as hello world, might be in green or red, and so on. The specific colors will vary from site to site, but the color coding helps highlight different pieces of your program as you write the code. Okay, now we have a program entered into the system. To see the results, let's press the Run button or Execute button located somewhere above or below the large main box. So, sometimes if you watch really closely when you press Run, the button might briefly change to Stop while it's running. Or there might be another Stop button that becomes available. And you can hit that Stop button if you want while the program is running, and it should stop the program. Well, when you run the program, the output window will appear if it wasn't there already. On some websites, this output window will be visible all the time, but in others, it only appears after running a program. This output window might be labeled execution, or console, or result, or even input. If you typed everything correctly, the output window will show the words hello world. And if you made a mistake typing in the program, then you might see an error. It could be in the same output window, or it might be in a different window, or a different tab of an existing window. So, here, I accidentally typed out instead of cout. So, when I run it, I'll get an error telling me that out is not declared in this scope. So, I go back to the code, I fix the error, and then I press run again. If everything just compiled normally, then when we try to run the program, we should get the correct output in the output window. Once you get a correct output, then go ahead and create an error in the code yourself. Delete a letter somewhere. For example, remove the last character from the first line. That's the angle bracket that looks like a greater than symbol. And if you try running this, then you should see a compilation error message somewhere. And you might need to look at the compilation tab if it's separate from an execution tab. And the error will list something here, like 1:18, and then an error message. The 1:18 at the beginning is telling you that there was an error detected on line 1 in the 18th character. That's where the character was removed. The message, missing terminating greater than character, tells us that we're missing the closing angle bracket. The error message should give you clues about exactly what prevented your program from running successfully. And different websites' compilers may have different error messages. Okay, so you can enter a program, modify it, and run the program. However, just remember that any program in the browser window is not really being saved anywhere. Typing into a browser window might be okay for small programs like Hello World. But if you were to write a really large program, you'd really hate to have your browser window crash or accidentally close it and lose all your work. Just refreshing your browser can lose all your work. So, it's up to you to make sure that your code is not lost. I would strongly recommend that whenever you have programs that you type into the browser, you also copy and then paste those programs into a document on your own computer. Saving in plain text is best, since that won't introduce extraneous information and formatting that a full word processor might add in. If you save your file with a .cpp extension at the end, that's a signal that it's actually C++ code. Lastly, I want to point out a few limitations of programming in the browser. First, there is no guarantee of reliability. The website could go down briefly at any time. And second, some browser compilers will not let you create and store your files on their computer. On those websites, reading and writing files, as we discuss in Lecture 10, would not be possible. And third, there's no security or privacy. The browser shell is not running on your machine. It's compiling and running on some other machine. You should not be entering sensitive or proprietary information into this system. Still, a web interface is probably the simplest way to quickly try out a program and see the results. The browser is an easy way for you to do 90% of what's in this course. When you're ready to move beyond browser-based programming, using an integrated development environment, or IDE, will provide greater capabilities. It just takes a little bit more to set up. There are two main steps to follow. First, downloading and installing the IDE, and then writing and running your programs. I'll give you some advice about each. Again, I recommend using Visual Studio, the free Community Edition, on Windows, or Xcode on a Mac. To use an IDE, you'll need to first download and install the IDE on your computer. On a PC, this means going to the Visual Studio Community homepage. Just enter Visual Studio Community in a search engine or type in the address directly. Click the button to start the download. That will download the installer, which you then need to run to actually perform the installation. To download on a Mac, you'll go to the App Store, find Xcode, and install from there. When you install, you'll need to follow any particular installation instructions. If given the option, you'll want to specify that you want to use C++. For example, in a PC installation, this will mean selecting the desktop development with C++ workload when you're asked to enter a workload. Now for the most part, just let things install in their default ways in default places. In most such cases, the installation will go smoothly. We've provided supplemental documentation at the address shown with even more detailed steps and tips for downloading and installing. You may be fine with the information provided here, but if you do run into trouble, please see that supplemental information for additional help. Once you have your IDE installed, it's time to try writing and running a program in the IDE. Find the IDE you installed on your system and start it up. Now when you start the IDE, the first thing you'll need to do is create a new project. The project will hold all of the C++ files that you're creating to generate your program. You can create new projects for different programs throughout the course. Our individual programs will mostly be just one C++ file per project. Setting up a new project is a little different in Visual Studio and in Xcode. Briefly, in Visual Studio, you'll create a new project, selecting Empty Project when you have a chance. On a Mac, you'll need to select that it's for your operating system, the Mac OS X, that you want a command line tool, and that you want a C++ project specifically. In both IDEs, you'll need to pick a name for your project. Make it something descriptive, such as Initial Project or Great Courses Lecture 1. See the supplemental documentation for more details about exactly how to set up your project. Now, once a project is created, you'll need to have an actual C++ file that will hold your program. In Visual Studio, you'll need to add a new item to your project, and that new item will be a C++ file. You get to choose the name of the C++ file. In Xcode, the file will be provided automatically, and it will have the name main.cpp. You just find the file listed under the project folder and click on it. Once that's done, you'll be able to enter your Hello World program or whatever code you want to write. When your code is entered, it's time to compile and run. In Visual Studio, you do this by selecting Start Debugging or Start Without Debugging from the Debugger menu. After the first time running, you'll also just be able to click a little green arrow labeled Local Windows Debugger. In Xcode, you'll just hit the Build and Run arrow near the top left. And when this happens, you should get Hello World output to a window that pops up. In the Mac version, that window will appear at the bottom right of the Xcode window. In Visual Studio, a new window will pop up, very briefly, but it will disappear as soon as the program is over. So, here's what I recommend. To keep that window open so that you can actually see what's output, you'll want to add one small line to your code. Simply add to your code this very short line. System, open parenthesis, quote, pause, quote, close parenthesis, semicolon. Be sure to add it as the very last line before the final curly brace. This system pause line of code basically says, pause the system until the user hits a key. And this system pause command will keep the window open for you so that you can see the output. Just to see what happens, you might want to also make an intentional error in your code. For example, leave the C off of the word cout. And that should cause a compiler error, and you'll see how your IDE identifies and reports the error to you. Again, if you have trouble or you want more details about any of this, please see the supplementary documentation that we provide online. Now you're ready to develop your own programs in your own IDE. Happy programming!